All right, so today we are doing composition of functions. So 1.4 composition of functions. Before we get into today's lesson, remember, I don't know if I told you or not, I will be out tomorrow. Now, for those who've had me before, when I am out, our lesson still works just like it normally does. So we're doing the video today. You will have a video of me teaching the lesson tomorrow, classwork, homework, everything. So it'll still work exactly the way it always works if I was here. If you have really two options as a class on how you want to go about it. Their video for the lesson will be on Google Classroom. If you just want to bring in a pair of headphones, do it individually, pause, rewind, fast forward, however you want to do it, that's fine. Or if someone wants to actually take their laptop, plug it into the HDMI output, you can put it on the screen and y'all can do it as a class. Makes no difference to me. As a class, y'all decide that tomorrow, okay? Or some combination. If you do it through the board, you should get better sound because you'll come out there. Hopefully the sound works well, but I think the headset, sometimes the sound's not great. Anyway, that's tomorrow. So because of that, homework from today and homework from tomorrow are due on Tuesday, okay? Because I won't be here to check homework tomorrow. And of course, no school Monday. Composition. What is composition of functions? Okay, but they're made of. So when we do composition of functions, first, this right here, does that look strange? Yeah, it means f of g. We're used to seeing f, maybe a dot g, meaning I multiply two together, but that's not what we're doing here. That f is f of g. Now, this can be written two ways. It can be written like this, or it can be written f of g of 3. They both mean exactly the same thing. It is just two different ways of writing it. Okay, two different notations. They mean the same thing. When we do composition of functions, we're taking a function, we're just sticking it inside another function. Regardless of my notation, which one I'm using, the first one listed is my outside function. So we're going to start with the outside. Which one's the first one listed? F. So F is the first one listed. So I'm going to come over here and say, oh, there we go. There's my outside function. I'm going to rewrite my outside function, but every time I see the variable, I'm going to replace the variable with parentheses. Nothing else, just the variable. So if I replace the variable, I'll say 3. Oh, there's a variable. So parentheses minus 5. Inside of those parentheses is going to be my inside function. So what is my inside function? X squared. Now, two major types of composition we're going to do today. One is f of g of x, and one is f of g of value. Do you see how this one has a value right there? If that was just an x, I'd simplify that. That would be my answer. If it's a value, I'm go one step further and I plug that value in to my variable. So we'll say, okay, leave everything the same, but now I'm plugging that into my variable. Three squared is 3 times 9 is And 27 minus 5 is 22. That's my answer. So when I do composition of functions and I have a value here, my answer is going to be a number, a specific number. By the way, added benefit of doing the little zoom stuff is I get a lot more colors I get to choose from instead of just the same 3 or 4. Questions on number 1? Does that look familiar? Yes. Okay, hopefully that looks familiar from after what, with maybe the exception of the very last thing we do, which is actually one of the easier ones. Nothing should be new about today's lesson. This should all be a reminder. Go ahead and try that for number 2. All right, which one is my outside function? F. So I'm gonna write F, -9, parentheses. What goes inside my parentheses? And I'm going to go ahead and combine steps a little bit and say square root. I'm just going to go ahead and put parentheses -9 because I know I got to put a value in for x. And yes, we're going to put 10 in. All right. So inside my square root, we have 10 minus 9. What's 10 minus 9? And then I have square root of 1. What is the square root of 1? -9 times 1 minus 9. Well, anything times 1 is itself. -9 minus 9 is we're going to come back and do 3, but first I want to skip down to number 4. Number 4. What's my outside function? G. They switch the letters. So parentheses squared. What goes inside my parentheses? So -3x plus 4. Now, I'm actually not going to do anything with the -2 because I want to skip ahead this one to show something. Let's say that I'm not plugging a value in, I'm just simplifying this with the x. If I was to simplify that, could I simplify that to be that? No. Yes, no. Maybe. No. No. Give me some no's. Why not? What's wrong?
replacing the X, you're not replacing the bold.
Say it one more time.
You're replacing the X, you're not replacing everything else. So the X is the only thing that you're showing.
Well, no, so right here. So as I was putting that inside of here, right? Yeah.
I do the same.
So the red and blue part's correct. My question is, can I go from here to here? So let's shoot a square. So -3 squared is 9. X squared, 4 squared is 16. So is that good? Is it? Okay. So what is that? So it's a good color. Okay. Very, very loudly. I'm going to show you this one time, and hopefully you'll remember this for the rest of the thing. We're going to scream no as loud as we can. Are you ready? 1, 2, 3. No! Okay. Whoever goes back and watches this video is going to be really upset at that point. I cannot do that. And here's why. What does it mean to square something? So that is the same thing as -3x plus 4 times -3x plus 4, correct? Now, you've multiplied stuff like that out. How do I multiply that? Okay, so you can use your box or FOIL or distribute however you want to. Either way, those two multiply and I get 9x squared. Oh, okay. -3x, I'll distribute over here. Change colors here. 4 times -3x. And then 4 times 4 is. Okay. I still got the 16. There you go. There and there. But what am I missing? What was I missing the first time? The middle terms. And those two combine to make -24x. Okay. Now, there is a trick. That's a little bit of a step. There is a shortcut to get that middle term. Square my first one, because really both this worked. I'm just short one term, right? Both of those terms are correct. I'm just missing one. To get my middle term, all I have to do is say 2 times this, which is, times that, which is -24x. Okay? So if you don't treat it like a square. If you treat it like 2 times this, that'll always give you your missing term, your middle one. Okay? Sometimes that confuses people and they're like, no, I'd rather just multiply them out. That makes sense. Either way. Okay? Now, I realize you're looking at that like, none of that applied to this problem because we're supposed to plug -2 in for x. Yes, I know. But this pops up a lot. It's going to pop up later today in this class. It's going to pop up pretty much throughout this whole year. So I wanted to try to use this opportunity to point that out now so that we don't fall into that trap. Now, I could have done that. And so my final answer here was 9x squared minus 24x plus 16. Plug the -2 in. -2 squared is +4. 9 times 4. 24 times -2 is 48. 36. And that gives me 100. All right.
That's so much work.
No,
Like I
just
did in 5 seconds.
yeah, I know. So again, I'm not saying this is how you would actually do this problem. I just pointed this out because in a little bit, you're going to get where you have to go here. You're not plugging a value in. So if you don't have, yes, or this one was much easier. You could just plug -2 N for the X, simplified real quick. I got you. The problem is we're going to have a lot of times where we're not plugging a value in. You're just simplifying with X's. And so that's why, because it was there, I used it as an opportunity to show that that's not right. Okay. So yes, because you can just plug the value in, great. Plug the value in right there. You don't have to worry about it. But in a little bit, we're going to get to just X's. So go ahead and go back and do numbers 3 and 5.
What? I did 12 minus 8, right? 12 minus 8 for negative 4 times 4 is negative 4 is negative 6. Triple 80, right? Right, right.
The red monkey separated.
So we set it up. Is that what we had? 12 minus 8 is 4. Square root of 4 is negative 4 times 2 is Number 5. What's my outside function? G. All right, so do be careful because they don't always make F the outside function. So here's G. All right, 2 times -2 is -4 plus 1 is -3 squared is none. 9 minus 5 is, and the square root of 4 is 2. So once I get to number 6, what's different? Yeah, so I'm not replacing x with anything. I'm plugging in and simplifying. What's my outside function? Put parentheses where the x is. So some of these require very, very little simplifying. This one right here, I just put the x to the 4th in. And I'm done. -9 x to the 4th plus 3. That was it. Nothing I can do to simplify that any further. Some of these require a little bit of simplifying, maybe some combining like terms. Some of these require more. And there's at least one that requires you to actually square a binomial, which is the whole tangent I went off on, okay? So see if you can finish the ones in this section. So that would be numbers 7, 8, 9, and 10. Try 7, 8, 9, and 10. If you get stuck on one, I'll be walking around to help you. Yes, so basically distribute it.
Those are like 4.
Yeah, you read 4, and then 2 of those terms should combine. Just the ones in that section. So 7, it is 4.
Yeah.
So number 8. Thank you.
I ain't doing it.
It's only 8.
You should be. So it's not. Oh shoot.
This next.
Got the money.
8x squared plus
8x. 16x.
8x squared.
16x.
Oh yeah, I did square. I added it. Yeah, 16x squared.
16x. You got 16x.
Yeah.
That's wrong.
Can't square like that.
What?
Yes.
Yeah. 4x weird.
You gotta.
Oh wait, you gotta square the x.
Yeah. So what you
gotta put
x squared.
So you did 2 times 3, right?
Which is 6.
Plus,
Oh, 9?
Not plus.
yeah.
Oh, you squared the 4 x. Square the 4.
Right, but I'm saying you can't square it like that. Because remember, it's gonna be a middle number. You can't just square it. Remember how you did on the board? That's why you gotta write it out. It's squaring itself. So do 4x. 4x plus 3. Parentheses.
That's not even the same, bro.
It's the same thing. You can't square like that. All right, just wait.
What you got?
What? Just watch. I'm about to do it now. That's what I'm saying. You can't.
Wait, how you do it? Like, I know you're talking about this shit.
But you never will get an answer.
You're right.
Because it's simplified.
All right.
There's no answer. Because
Look, so yeah, you supposed to do it like
this, right? That's right.
Okay.
And then you go in every like that.
3.
Yeah.
Yeah, I know you come up. No, because he's talking about he talking on the board. You can't square x by itself. I knew you talking about.
You got 8x. 8x squared.
I get 8. 4 times 4.
2
I got 2 points.
plus 24.
Yeah, that's on 4.
Plus what?
No.
Yeah.
But you can simplify that.
Or simplify. Yeah, that's what I'm saying.
Yeah.
That's how I got 8.
I'm like,
All right, so since you've already seen me lead lots of these, would anybody like to volunteer to do number 7 on the board? You do number 7? Okay.
Oh, God. Yeah, I'm gonna need to focus, all right? Need to lock it up. Oh, dang.
Thank you. Questions on number 7?
You got it? So everybody on the same thing?
Number 8?
Not doing that. I don't know.
I don't have the answer sheet. Just assume if you got it, it has. Ooh. All right. So when you go over there, you got multiply like you did here, right? Multiply by itself. You got it. You can do it. It's easier up here on the big whiteboard anyway. There you go. You can move out your way. No, you're good. You're good. You're right. Yep.
Yeah, you can do it though.
Oh, okay. So I used the little eraser. That's the problem with Zoom. The Zoom is hit the top one. So hit it. Yeah. Very good. Thank you. All right. So this was, I think, the first time that we call it squaring a binomial. The squaring a binomial trap came up. So make sure we're watching out for those. Besides the obvious squaring a binomial trap, one of the traps of this is you do all this work doing the x minus 3 squared. A lot of times you can forget that to keep that plus 7 there. Sometimes I'll see students just kind of leave that off because you're so caught up on trying to square that, you forget there's that number added to the end. So a lot of moving parts. So there's no one thing about these that are difficult. There's just a lot of different parts to it. So just make sure you're taking your time, paying attention. All right, that was number 8. I think I can leave that there because we got room right here. Who's going to do number 9 for me? Yeah, we'll move this down. Here. There we go. You can sit in the chair and do it if you want to. It makes it a little easier. Slower. That's good. Yeah. And so this one was just the binomial trap, but you had some coefficients in there to do math.
You're not simplifying. Simplify.
Yeah, so you can't simplify that because that's an x squared, that's an x, that's a constant. None of those are like terms. Yep. Okay. One more, number 10. Who's got number 10 for me?
I'll do it.
You got number 10? All right. Number 10 was a bit brutal.
Or no. Yeah, that would work.
Yeah.
It'd be -9, right?
All right. Oh, so go back here though. Where did that 2 come from?
The 2x.
Yeah. So I see the x squared. Where?
Oh, yeah. Never mind.
Okay. It's okay. It's right here. So I think everything else was good. I'll just get rid of that 2. All right. So a lot going on this one, but there's one thing about this one that was different than all the others. What was the thing that was different about it? It had 2 x's, so you had to plug in twice. Okay. So, and this is how you do that, because every now and then I'll see someone like, oh, well, I'll put the x in the first one and the -1 in the second one. No, you got to plug the same thing in for both x's, and it had a binomial square trap in it. And yeah, x squared -9. So I found. And a problem like that can be misleading because you go into assuming, okay, it has to be some massive thing. There's no way it can simplify to something as small as x squared -9, but it really does.
What the x -1? You see the 2 in front of the.
Right here. Yes.
So there's only that only applies to one set of parentheses. Like.
Yeah. So that 2 is just distributed to those 2.
Okay.
Yeah. And it's because of that. It's 2 is only on that x, so you're not distributing it to the negative. Yeah. Questions on that middle section? Okay, so now we get to our last section. This is my favorite section. And this section is actually the part that's probably different than Algebra 2. I think the first 2 sections we do in Algebra 2, I don't think we do, at least not in my class, we do these in Algebra 2. But these are funner. They require a lot less work. It's more just looking at it. Funner. I think that's a word, right? For right now, it will be. Sorry, Lane's back there judging my English. All right. This one we're working backwards. Okay. So right up here, it says we always have h of x kind of is our answer, and we're doing f of g. Okay. So they actually give me one of the original ones and my answer, and they're asking me for the other one. So they're saying, what did we put into f that gave us h? Okay. So it's not really anything you're going to do as far as multiply. You're really just kind of looking at it, kind of analyzing it and writing out. The first one's not too bad, and most of these are not. What do I put into f? So think about if this is my outside function, that means I do something squared. G is what I put in. What do I put in to give me that? Yeah. So my answer for this one, sorry, I drew lots of arrows all over the screen. That was confusing. So my g of x is 2x minus 5, because that's what I would plug into f to make h. Make sense? Simple enough? All right, see if you can try the rest of those real quick.
Who in front of them? Yeah, you can spell it.
All right, we get a chance to finish those? Awesome. So number 12, what is g of x? 13. And number 14. Negative 3x minus 2 cubed. Why do I need to make sure I have the cube there? because it's right there, but it's not right there. So everything that's not in F has got to be a part of G to be able to get all of it. So yeah, cubes. Simple enough. All right, so homework's a little different in that it looks different. It's the same thing, but it looks different. So we're actually going to go over, this is in 4 sections. We're actually going to go over one in each section on your homework together. That's also why I tried to leave a lot of time to do that. Let me hand that out. In a lot of ways, it's actually easier. You don't get, I don't think we have any problems as bad as like number 10 was on your classwork. Yeah, no, I have had one person circle like A. That's not how this works. Okay. Now, for number 1, it seems like part of the problem is missing. That's because they tell you in the instructions, they're all F of G. So they're not like switching up, they're not putting like F of G sometimes in G of F. They're saying, okay, we're always going to do F of G. Okay. So for the first section, you're just doing F of G. And these are really simple functions. So these are not hard, except for like F and G are a little different. How are F and G a little different? We got an e to the x. Now, hopefully you saw that in Algebra 2, but you may have forgotten. And we're going to go over it like it's brand new in this class, but we haven't yet. And so I'm going to go over one like that. Okay, so let's start off with, we're going to do F together. So I told you we're going to do one in each part together. So I'm going to do F together. What is the outside function? F. For all of these, the outside function is F. So I'm going to replace F, or sorry, I'm going to replace the X with parentheses. So E parentheses. Okay. What goes inside those parentheses? And other than write it without parentheses, we're done. That's it. So
This is a variable.
E is not a variable. E is a number. Does anybody know what number E is?
I remember about it.
2.718281828. Dot, 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 dot. Keeps going. It's actually on your calculator. In fact, if you take your phone calculator, turn it sideways, you probably have it on there too. So E is just a number. Okay. We'll get into that in a later chapter, but E is not a variable. X is your variable. There, everybody see how we did that? So for all of these, just like we did, F of G, put G inside of F. All right, clear? Slide down to section 2. All right. So this one is saying do both. So each one of these is 2 parts, saying, all right, plug F into G. That's one part, and then plug G into F. And they have a couple that are super simple, but they're so simple that we didn't talk about in our classwork, and they tend to confuse people. So we're going to look at number A. And yes, we're in algebra, so, or actually we're in pre-cal. So letters are numbers too, so I can say number A. So it says there's 2 parts to each one of these. So we're going to say F of G. If I do F of G, that means I take F and say, all right, parentheses squared plus 1. And then what do I plug in there? Yeah, I plug G, which is square root of 3. Now, I have a square root of 3 squared. What happens when I square a square root? They cancel out, and so I just get 3 plus 1 is 4. That was F of G. It tells me up here to do both F of G and G of F. So G of F. What is G? Square root of 3. Is there an X? So my answer is square root of 3. Okay. If there's no X to plug into, that's just it. So if there's that's a constant, that's just it. It's like you can't plug into anything, so it just stays that. All right, there you go. That was part A, number 2. The rest of this is pretty obvious. Okay, so far? All right. Number 3, we did one like this. I'll ask you, which one of these do you want me to do? A, B, or C?
C.
C has a trig function in there, right? That scares us. So here's F. We have X cubed. It says we're plugging G in. We're trying, just like what we did on the last section of our classwork, I'm plugging a function into F to make this. Well, it's X cubed. That means I have something cubed. What did I plug into my parentheses to make H? So G of X is sine of X. Yes. We'll talk about sin later, but yeah, I had to get my pulpit after that one. All right. Very good. 1, 2, and 3. All right. Flip over your paper. There is one side on the back. There's a back. All right. So these are really just like section 3. The only difference is they don't tell you what one of the original is. You have to figure out both of the originals. Okay. Now, you are not allowed to use X as the original. Okay. It's got to be something other than just X. So let's look at, well, actually, you tell me, which one do you want me to do? E? Okay. So this one right here. What do I notice seems to be like an inside part? X squared plus 1. So I'm going to do that. I'm going to say that G of X is X squared plus 1. By the way, there are multiple ways you could do these. If that's my inside, that means that whole thing right there is my G. That whole thing right there is my G. That means everything else had to be F, correct? So I say, okay, F of X has to be square root. Well, if I plug G in, that means there has to be what inside of there? X. So square root X minus 1 over what? Square root X plus 1. And there you go. Does that make sense? I told you there's multiple ways. I could have made G of X square root of all of that, in which case F would just be X minus 1, X plus 1. They both would work. Okay, so that's why I said there's not necessarily one specific way that you got to do these. All right, there we go. That was an example of each one. Let's try to leave you time. Yep, we still got 15 minutes. So there you go. Try to leave you plenty of time to work on that in class. So if you're going to start working on those, if you have any questions, let me know. Yes.